we're trying to figure out where this isn't differentiable. And so it looks like there's two spots. Okay, it looks like we have some concerns at x equals 0 and maybe at x equals 1. Okay? The reason I say x equals 0 because that's like the end point, right? So we still proceed like we did before though. So we say the limit as h approaches 0 from the negative side is going to be well, actually, you know, we don't even have to do, x equals 0, we know that's the one, because I can't even take a limit, right? I can't approach from the other side. Does that make sense to you guys? So really our only point of interest is x equals 1. Okay? So we would say 1 plus h minus f of 1 all over h. Now remember what I'm saying is that f of x is equal to the square root of x. Well, that would mean that f of 1 plus h would be equal to the square root of 1 plus h. Does that make sense? And f of 1 would be equal to the square root of 1, which is equal to 1. So if I plug all that stuff in, I got 1 plus h, the square root of that, minus 1 all over h. Okay? Now this is a tricky one. Whenever we have a square root, usually we have to hit it with a conjugate, and that's the only way we can get rid of this h on the bottom. So I would say the square root of 1 plus h plus 1. Whatever I do on the top, I have to do on the bottom. Now what that'll do is that'll help us pull out that h out of the square root, and we'll have an h on the top that can cancel with the h on the bottom. So what I end up with is 1 plus h minus 1, right? So it's the square of these two radicals and then the difference of 1 squared, which is just 1, all over h. Okay? Times 1 plus h, or the square root of that, plus 1. Okay? So the 1's cancel and I'm left with h on the top. Oh wait, this h cancels with this h. So really I'm left with a 1 on the top. When I plug in the 0 for h, I get the square root of 1 plus 0, which is really 1 plus 1, which is just 2. So if I take the limit of this thing as h approaches from
Wait, why is it
0 from the left-hand side, huh?
Why is it 2? 1 plus 0 is 1.
Yeah, so you're going to take the square root of 1 plus 0, which is just 1, and then the square root of 1 is just 1, so 1 plus 1 is 2.
Okay.
Does that make sense? Now, if I do the same exact thing,
Why was f of x equals 1 up on the top? Because doesn't f of x equal the square root of 1 plus h?
no. Okay, so look carefully. Let me explain to you guys, okay? F of x equals the square root of x. F of 1 plus h equals the square root of 1 plus h. Well, if f of x equals the square root of x, then f of 1 is equal to the square root of 1. Or just 1.
Okay, so we, okay.
Does that make sense, or you just...
Yeah, so we didn't really need to do the stuff up top there, we just did that.
I just wrote that out so you guys could see where the stuff was coming from. Okay? So now for the next one, what we want to do is we want to take the limit as h approaches 0 from the right-hand side. And so really the only thing, everything else is pretty much the same, it's just we're going to use different equations. So the setup's the same, but now f of x is equal to 2x minus 1. And so that changes that. So now, if that's the case, then f of 1 plus h is equal to 2 times 1 plus h minus 1. Or 2 plus 2h minus 1, or h plus 1. Okay? Does that make sense? Okay, so now the other thing I need to figure out is what is f of 1? Well, f of 1 is 2 times 1 minus 1, or 2 minus 1, or just 1.
Wait, is it 2 plus 2?
Yeah, isn't it 2 plus 2?
Ah, yes. So this would be 2h. Good catch, guys. So then on the next step, I would say the limit as h approaches 0 is going to be 2h plus 1 minus 1 all over h. Now remember, Mr. Adams has said this like a gazillion times. If we did things correctly, every term that does not have an h in it should cancel out at this point. And they do. So I'm left with 2h over h. The h's cancel and reduce down to 1 over 1. So then the limit of this, as we approach 0 from the right hand side, is really just 2. Right? And then when we approach from the left hand side, and I'll just transpose it right here, what was that equal to?
1 was 1/2.
1 was 1/2. So what can I say? Well, I could say that f prime evaluated at 1 is does not exist.
So for this particular problem, we plugged in 1 because it was, the point P was at 1, 1.
Right.
So whatever the point is,
Yeah, when we really focus on the x. So the question that she's not really asking a question, she's just kind of asking to be reaffirmed, but we chose this point because it kind of looks like a cusp, right? And that occurs at x equals 1. So the way that we could check to see if it's differentiable or not is to take the left-sided derivative and the right-sided derivative. Now if they equal the same, then we're in business. If they don't equal the same, well then the limit or the derivative doesn't exist. So that's why we chose 1 plus h and f of 1. Does that make sense? That's a good question.